All right, 7.3, number 7. It says the base of a solid is a region between the curve y equals 2 square root of sine x and the interval 0 to pi on the x-axis. Got that here in the drawing. The cross sections perpendicular to the x-axis are equilateral, so two parts. In part A, they're equilateral triangles. Part B, they're squares with a base running in the xy plane. Okay, so for the equilateral y plane. Okay, so we have equilateral triangles. There's my triangle, and we have a whole bunch of them from 0 to pi, and we have to add up all of those to get the volume. So remember, in cross-sectional problems, you're really only integrating a of x dx from a to b, so from 0 to pi here. So if we can figure out what a of x is, we have our integral set up. So a of x is this cross-sectional area, or that triangle, written in terms of x. Okay, so if we have an equilateral triangle and we know the base of this right here is just 2 square root of sine x, if we know the base, then we can find its area. Well, generally, if I know one side of an equilateral triangle, I'll just call it x here. The area of the equilateral triangle, if I'm going to chop it up, if it's equilateral, that means it's equiangular. So this is 60 degrees, that's 60 degrees, that's 60 degrees, which actually makes a 30, 60, 90 triangle here. I should have drawn my triangle bigger. And this is bisected on the bottom, so that's x over 2. This is also x, because that's the same as all three sides. So if I zoom in on that one triangle, I have an x over 2. I have an x, and this is 60, and this is 30. So 30, 60, 90 triangle, half of the side opposite 30 is half hypotenuse. We already have that. But that side opposite 30 times the square root of 3 is going to be the other leg of the triangle. Okay, so the height of this triangle is square root of 3 over 2x. So now we can find the area of this triangle. It's just 1/2 base times height. And the base is that whole thing x, and the height is square root of 3 over 2x. So the area of an equilateral triangle, if you know one of its edges, is square root of 3 over 4 times the edge squared. Alright, so that's a whole bunch of geometry. If you want to memorize that, you don't have to go through all that process. It's square root of 3 over 4 x squared. Well, this edge of the triangle is not x, it is 2 square root of sine x. So it's now going to be the integral from 0 to pi of square root of 3 over 4 times the edge squared, which is 2 square root of sine x. Okay, and the only thing we have to do now is just clean up our integral and we'd be done. In this assignment, I wouldn't ask you to you don't have to evaluate the integrals by hand. If you set them up, check your answer in the back of the book, you're good, just to save some time. So this 2 squared is going to be 4, and that'll get rid of this 4. So it's the integral square root of 3 sine x dx from 0 to pi. So there's part A. Part B is square in the xy plane. So there's my square. This one's a little bit easier, quite a bit easier. The base is 2 square root of sine x, and we know that a of x would just be 2 square root of sine x, the quantity squared. That's what a of x is, because it's the bottom squared. So we would just integrate it from 0 to pi, and you could clean that up. So it looks like 4 sine x dx from 0 to pi. If we were going along perpendicular to the y-axis, then you would be integrating with respect to y. But since we're incrementally increasing in the x direction, we're integrating with respect to x.